Assalamualaikum. My name is Muhammad Ali Mezainal. My magic number is MA20100. I am going to present on the introduction. In this project, we are looking forward to solve some question in our mind. The question are how the sound energy works and what sensor can detect and how we can analyze the signal using the Daisy Lab program. This project will be dedicated to answer this question. For the measurement input, we decided to choose an electric shaver. This is the principle of application for the dynamic microphone. The sound wave hit the diaphragm and make it vibrate and cause the voice coil attached at the back also to vibrate. Then it creates a field by the small magnet that surround the voice coil. The magnet field then can produce an electric signal whenever the voice coil vibrates. This is the condenser mic. The voice coil is replaced with a backplate. The principle of application is the same like the previous one. This is MEM microphone. It is super sensitive. It has echo and noise cancellation and it has beamforming.
My name is Instrumentation, and I'll be presenting about Chapter 2, Literature Review. Acoustical measurement and instrumentation. It is vital for work in many fields such as production and process control. It is required in order to comply with standards form of ANSI, IEC, and ISO. The main components are sensors, data acquisition, and analysis. For the microphone, it is a tool that receives sound waves and converts them to electrical signals. The most commonly used ones are condenser, dynamic, and ribbon microphones. Frequency response for condenser and ribbon microphone are around 20 Hz to 20 kHz, while frequency response for dynamic microphone is around 40 Hz to 15 kHz. The shaver machine is a tool that is used to shave off or trim facial hair. It is powered by a battery or can be recharged. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mahman and Akib Farazan. Okay, today I would like to present to you about the chapter 3, which is methodology. Okay, first of all, I will introduce you about the three components for system requirement, which is first is electric shaver, second is Daisy Lab software, and third is sound meter apps. Okay, first of all, we must set up the Daisy Lab, which is the module. If you can see the module, in this module, we have analog, digital meter, formula, digital meter, and write 00. So that we have YT charts, data windows, FFT00, and YT charts 0.1. Okay, after that, we must to set up the measurement, which is sapling rate 10 kHz, and the block size is 20,000. So we must download the sound meter application on telephone, so we can get average sound meter. So what I get on my project is average sound meter is 81.4 dB, which is decibel meter. And what I get on average, I substitute on this formula, which is to get VREF. So I get this 0.00009160, and we can get on digital meter, which is 1.16. After that, we substitute on this formula, and this formula we take on that formula. Okay, I pass to the next presenter for the result and discussion.
I'm Liu Peikai, and I'm going to present the result and discussion of this project. Based on the Daisy Lab, the IMS value we get is 1.18 and the decibel value we get is 80.49 dB. From the time domain graph, we can find that the peak voltage is -5V. Besides, we can see that the audio frequency have no effect on the amplitude. Furthermore, we perform a FFT waveform analysis in the Daisy Lab setup to create the frequency domain graph. Based on it, we found out that the largest frequency peak was 94 Hz at 0.47V. Based on the average decibel value 81.4 dB obtained using the sound meter app on a smartphone, and the decibel value we get from the Daisy Lab, we calculate the percentage error value and get a result of 1.118%. It is recommended to use the value from the DesiLab compared to the smartphone sound meter app because different phone features may cause the frequency to be disturbed. For instance, apps on Android lack the features and functionality of iOS apps.
In conclusion, we have managed to get the objective completed. We managed to analyze the signal from the electric shaver using the DesiLab program. The error that we get during project is 1.12%, which is lower than we expected. This is the sign that our project is successful, but there always room for improvement. We can improve the error if we conduct the project in a controlled environment, such as conducting the project in the soundproof lab. I think that's all from us. Thank you.